Eric Siegel.
All right, everyone, thanks very much. So, prediction as a capability is the holy grail for sales and marketing. But isn't prediction supposed to be impossible? The only thing certain is uncertainty, death, taxes. The weather can only be predicted, so, well, human behavior, no less challenging to predict. How do we put credibility on the claim predictive analytics makes by calling itself that? That's a credibility question that I will address partway through my presentation. So just a couple words about my work. I'm the founder of the conference series Predictive Analytics World. It takes place 10 times a year and is the leading cross-vendor event. And as our voiceover guy, who I love, I want him to follow me around everywhere I go, said I'm the executive editor of Predictive Analytics Times. Check out predictiveanalyticstimes.com for lots of content articles. It's a news portal. But there's also full-length session videos accessible for free from the conference series. And I'm the author of this book, Predictive Analytics. Now, the subtitle of the book provides an informal definition of predictive analytics: the power to predict who will click, buy, lie, or die. This is it's used as a textbook at 35 universities, but it's written in a pop science way. People call it the Freakonomics of Big Data, and I have 4 copies with me. So the first 4 people to ask me at lunch, I'll give the copies. Also, if you're interested in the audiobook version, email me directly, mention this event, and I can provide the audiobook version at no cost. If you tweet, I'm Predict Analytic on Twitter. So I'm going to talk about predictive analytics, give an overview, describe how it provides value in deployment for sales, marketing, and other applications. A little look under the hood at how it works, what a predictive model can look like, some case studies. So, how many people here, we talk about what is predictive analytics, how many people here are familiar with Nate Silver? Okay, most of you. So there's probably no more famous person of prediction, the most famous statistician, the best-known prognostic quant, has been on all the talk shows and gained perhaps the most notoriety for predicting the 2012 presidential election, the correct outcome for each individual state. So people say, is that predictive analytics? Did he use predictive analytics to do that? Does that count? The answer is no. But Obama did use predictive analytics. And this actually distinguishes the difference between predictive analytics and forecasting. What Nate Silver did is forecasting by way of poll aggregation. So for an individual state like Ohio, what's going to be the overall outcome as a trend across voters? Will it vote more towards the candidate Obama or the opponent candidate Romney in 2012, for example? Whereas in contrast to that, what the Obama campaign analytics team did was render a predictive score for each individual voter. That's the defining characteristic of this type of quantitative prediction, predictive analytics. And not predicting the outcome or voter behavior, whether they're going to vote Obama versus Romney, Democrat, Republican. But a more advanced form, arguably even more actionable form of predictive analytics, called persuasion modeling, where you're predicting for each individual, can they be influenced? Are they influenceable? Are they persuadable? In order to determine which doors to knock on. So a presidential campaign is a marketing campaign or a sales campaign. You're trying to promote a candidate for the office. And the army of volunteers is the sales force. And which doors to knock on was determined by a predictive model, determining which door to knock on, which phone number to call, targeting direct mail very much the same way. So the volunteers were not just pounding the pavement and knocking on every door in a neighborhood. They were only knocking on the doors that were on a list that was given to them by campaign officials, in order to drive, as well as we can, this voting behavior, that type of outcome. Right? Same concept for for promoting commercial buying behavior. I think there's an issue here with the... I'm not advancing. I'm only advancing the right slides. Oh, OK. Now it's going. There's two monitors on the right. You see the next slide, and that one's somewhere else. So commercial buying behavior, same concept. So in a nutshell, while Nate Silver competed very publicly to win at forecasting the outcome of the election, the Obama campaign analytics team competed very secretly. We didn't find out really about the details of this until afterwards to win the election itself, right? So which is more powerful? Predictive analytics, by virtue of that defining characteristic of predicting per individual, empowers an organization not just to predict the future, but to influence it, because each individual prediction directly informs decisions, treatment, resource allocation on that per individual level. And by the way, Hillary for America, as of almost a year ago, already had predictive analytics staff job positions on her website, specifically with that type of advanced predictive modeling called persuasion modeling. So it's powerful stuff. There's a famous article that was in Harvard Business Review, Data Scientists, the sexiest job of the 21st century, written by these two people, Tom Davenport, who actually wrote the foreword to my book, and DJ Patil, who subsequently is now appointed by the president to be the first chief data scientist of the US. So, you know, I consider these two guys very good looking, but sexiest job I always thought was reserved for firefighters, right? Maybe it's the hard hat. This is me dressed up for Halloween as a data miner. So I made a rap video to explore this question. And you can check it out at predictthis.org. This is the best ever educational predictive analytics music rap video. We've got dance, we've got choreography, there was lights, camera, and there was action. So the lyrics actually are educational. But the video is about what it means to be attractive even though you're a geek. So that's the concept there. So here's the real definition, a little more specific. Predictive analytics is technology that learns from experience. And by experience, I'm referring to data. So how many people here get excited when you think about data? Some of you are like a little shy at first, and then ultimately, probably more than half of you. Now, you probably realize that in general, people don't necessarily get excited about data. The word data is a deal killer at cocktail parties, which I know from personal experience. I have the data. But that's because we overlook and forget data is not just a bunch of arcane ones and zeros. It's a collection of prior events. It's a recording of things that have happened, so it encodes the collective experience of an organization, from which it's possible to apply these analytical methods to learn from it how to render predictions per individual. So each individual, right, which could be a corporate client or an individual consumer, whatever, gets a number, a predictive score, often in the form of a probability, and the higher the number, the bigger chance that they will, well, like in the title of my book, click, buy, lie, or die, right? Cancel their subscription, commit an act of fraud, become a bad creditor, commit a crime, any kind of outcome or behavior for which there may be value to the organization to predict, in order to drive better decisions, in order to determine those per individual treatment decisions, such as whether to expend more sales resources on this individual, whether to audit this individual's transaction for fraud, et cetera, et cetera. So in a nutshell, the core technology here, predictive modeling, takes as input from the left that experience, that data. It does the number crunching and produces what I depict in these slides as a golden egg. And that's the thing that does the prediction. So it takes as input one individual at a time, the variables, the factors that you know about that individual, and then derives the predictive score for whatever outcome or behavior you're intending to predict. So for example, in marketing, let's say you're looking at this individual on the left, you say, hey, should I expend the cost of contact? Should I apply this marketing treatment? What are the chances that if I do, the outcome will be positive and they'll buy our product? So getting to that credibility question I brought up, just how well can we predict? Nobel Prize-winning physicist Niels Bohr is famous for having said, "Prediction is very difficult, especially if it's about the future." Jay Leno, how come you never see a headline like "Psychic wins lottery"? Right? Which is a good question, right? It's actually really simple how we establish credibility on this bold claim, this audacious claim of predicting the future. You don't need to predict accurately to get great value. Predicting better than guessing and tipping the odds in the numbers games we play in business, in sales, marketing, and elsewhere, is often and generally more than adequate to drive value and render mass-scale operations more effective. So let's do a quick back-of-the-napkin arithmetic example to exemplify that. It's a marketing example. In sales, it's very much analogous, only slightly more complex. If I'm going to do mass marketing to these million customers or prospects, and it costs me $2 to contact each, if I have no predictive analytics and no way to target, I'm going to spend $2 million to contact everybody. If we end up with a 1% response rate, and it's $220 that we get back for each of those positive responses, well then, of the 1%, the 10,000, we're going to get 2.2 million in after spending 2 million. So we end up with a bottom line profit of 0.2 million, $200,000. So how much better is it going to be with a predictive model? If we use the results of a prior campaign, or let's say we applied the campaign over a random sample of like 40,000 of those million, or something like that, that's the history from which to learn. That's the experience. We create the golden egg, use it to score all these 1 million, sort them from most to least likely, and take the top quarter, 25%. If the predictive model is doing a pretty good job, maybe we'd get what's called a lift of 3. So we have a 3% response rate rather than 1, 3 times the overall average response rate in this sort of hot pocket that's been determined by way of 1 million individual yes-no decisions to contact or not to contact. So if we apply it in that way, and we suppress the other 75% from the list, the same little back-of-the-napkin arithmetic I did a second ago will show you that the profit bottom line skyrockets by a factor of more than 5 to $1.15 million, which is such a dramatic improvement just based on targeting more effectively, that I paid my graphic designer, who I paid by the hour, to draw this star explosion thing to make my point, drive it home. But, you know, wait a minute. This isn't actually accurate. We don't have high confidence that any individual this person's definitely going to buy. So in that sense, maybe this model really stinks, okay? But it's a skunk with bling, right? The value is undeniable. It's not necessarily about accuracy. It's about lift and how that converts to the bottom line. So I call that the prediction effect. A little prediction goes a long way. Predicting better than guessing improves bottom line performance, renders mass-scale operations, such as in sales and marketing, more effective. So let's go a little bit into how it works, what the data needs to look like, and what you discover from it. So let's start with a quote from Kung Fu Panda. How many people here saw Kung Fu Panda? Okay, how many people saw Kung Fu Panda and don't have kids? We should hang out. Like, yeah. So the wise turtle, Dustin Hoffman. Yesterday's history, tomorrow's a mystery, but today is a gift. That's why it's called the present. So let's take a slightly less sentimental or cute view on it. What do we have in the present that's a resource to help us predict this ultimate unknown, the future? Nobody knows it. That's the problem of life. Well, we do have two things in pocket that have the same relationship with one another, which is yesterday versus today. That is to say, we know for this individual that yesterday, when we applied this marketing treatment, we knew at that time that they were male, lived in California, had made at least 10 purchases, et cetera. Any and all demographic and behavioral data, any or all of which might help tip the balance in playing these odds, might be predictive in some sense, show a correlation. And then on the right side of the dotted line, we have something else that's also in the past, but it happened earlier today. We found out what the outcome was, which in this case was positive. So this is one example from which to learn. It's a learning case and corresponds to this one row of data. So in general, what you do with predictive modeling is you have one row per individual case, one row per customer. So if you just make a flat table, a long list of those examples that look like that, that table is the form and format that any predictive modeling project needs to get the data into in order to learn from it. And then when you do, you start getting all these great insights. So for example, people who go to a bar have a worse credit rating. More specifically, Canadian Tire issues credit cards, and then they look at how their patrons use the credit card with respect to whether they miss payments on their credit card bill. And it turns out that if you're observed using the card at a drinking establishment, you're more likely than average to miss repeated credit card bill payments. But if you buy the little felt pads that go on the bottom of your chair, you don't scratch the floor. How many people have bought those little pads that go on the good, okay, that's great. You got it together. You're a better credit risk. Go to the dentist, better credit risk. They unofficially told me larger dog collars, worse credit risk. Okay, you could try to explain it, but whatever your interpretation is, there's a correlation that helps predict. People who like curly fries on Facebook are more intelligent. Neighborhoods in San Francisco that exhibit a higher rate of certain crimes also show a higher demand of Uber rides, right? Not necessarily because the criminals are riding in the Uber, but because that's a proxy for non-residential population. How many people are in that area that don't actually live there tends to correlate with crime. So the data speaks, right? If you can interpret it, put it into that form and format of the training data, and learn to interpret it, do this type of analysis, it tells you things like dental patients miss fewer payments, right? So I call that the data effect. Data, for all intents and purposes, is always predictive. That's the excitement. That's the big in big data is the big value, the big excitement, because it has this characteristic. You're going to find correlations that help predict. But they don't necessarily explain, they don't necessarily tell you the causal reason. So for example, you could find in data that there's a correlation between ice cream consumption and shark attacks. And then you think, well, why would that be? What would be the relationship between those? Well, one might conjecture that when you eat ice cream, it makes you taste better, so you eat the ice cream, and then the shark eats you, right? But the probably more accepted interpretation is that it's seasonal, so it just so happens that when the weather's better, more people are swimming and at risk of shark attacks, and also more people are eating ice cream. So that is to say that neither of these things have a direct causal relation to the other, but the two are going to be correlated in the data. So it's important not to confuse correlation, which often is more than you need, and it means there's value, it helps predict, it helps build the model, the golden egg. Don't confuse that correlation with causation. So a couple slides, quick case study, bottom lines. These are the kinds of company presentations we see at Predictive Analytics World events a lot. These three are in marketing. First Tennessee Bank lowered direct mail costs by 20%, improving the return on investment of the marketing campaign by a factor of 6 by way of improving it with the targeting of a predictive model. The retailer Target does target their marketing, improved by 15 and 20%. Premier Bank Card reduced mailing costs by $12 million. In sales, paychecks, payroll service decreased by 40% number of phone calls needed to book a sales meeting. Many universities, such as Walden universities, do a lot of work in targeting their acquisition of students by way of scoring predictively, applying predictive models over the prospective students to help improve their acquisition of new students. Of course, a little bit of an older case study, Sun Microsystems, before it was purchased by Oracle, reported doubling the number of leads per phone call by targeting those efforts with a predictive model. I'm not going to have time to go over these, but you're going to get the PDF. A lot of my slides, by the way, have notes at the bottom with additional links and URLs and comments and such. So what I've been talking about so far is using predictive model to make a decision between active and passive treatment. So like Hamlet, to treat or not to treat, that is the question. But in many cases, obviously, there's no passive treatment. If you're making a phone call to a prospect, they're not going to say hello, and you're just not going to say anything. If they come to your web page, you're going to give them something on the screen. You're going to make a product recommendation. If they ask for a price, you have to make a choice. right? So in some cases, it's a choice between active treatments. And within that realm, you can actually look to your own personal dating life to help improve your analytical optimization of treatment choices. Right? Or conversely, next time you're out on a date, think about analytically optimizing marketing in order to improve your treatment decisions with your prospect, right? Because you're not there in the restaurant for food. It's a sales call. You're both the VP of sales and the product. So it's very important to predict ahead of time which outgoing message is going to lead to positive outcome, which will lead to negative outcome. Who here saw this movie, Groundhog Day, with Bill Murray? Okay, so it's a great movie. If you're one of the few who didn't see it, it's hilarious. Bill Murray's stuck reliving the same day over and over again, and he hates it. He can't get out of the cycle. He's in hell until he recognizes that this provides for him, as a salesperson, the unprecedented superpower to test different treatments on the same prospect under the same circumstance to see which leads to the best outcome. So let's watch a quick 47-second clip from the movie Groundhog Day.
You weren't in broadcasting or journalism?
Mm-mm. Believe it or not, I studied 19th century French poetry.
What a waste of time. I mean, for someone else, that would be an incredible waste of time. It's so bold of you to choose that. It's incredible. You must be a very, very strong person. Yeah? You weren't in broadcasting or journalism, anything like that?
Believe it or not, I studied 19th century French poetry.
La fille qui j'aimerais sera comme vont faire, que c'est bon fuira un peu chaque matin.
You speak French.
Oui.
Do not try that at home. So the sad news is you can't try it at home because in life there's no do-overs. So the only recourse is prediction. We've sort of focused mostly on targeting outreach, sort of for acquisition, for targeting sales, for targeting marketing. The other main marketing application that I've got to cover here in a few slides to make sort of the complete picture here is in what's called churn modeling, predicting who's at risk of leaving in order to target retention offers, right? Which is also part of sales operations depending on your boundaries and how things are defined. But the value proposition is interesting. It's sort of the other side of the coin here. Retaining existing customers is oftentimes considered much more cost-effective than acquiring new customers. And you can consider your current customer base as a balloon with the acquisition of new customers coming in as air flowing in from the left, and the loss, the constant ongoing attrition of customers, is that air leaking out the valve on the right. If we could just squeeze that valve on the right a little bit and decrease that attrition rate, how much more quickly would the balloon be expanding? That's the growth rate of your customer base. But convincing someone to stay who's otherwise going to leave can be expensive, often in the form of some kind of a retention discount or other type of incentive, not something you're going to expend on your entire customer base, obviously. So once again, the only recourse is prediction. Who's at the highest risk of departure? So you're looking at an individual, you're saying, hey, should I expend the cost of this discount? What are the chances that if they're like a magazine subscriber, they're going to be retained or we're going to lose them tomorrow? So this is the one point where let's look at a specific model that does churn modeling, predicting who's leaving, as the one quick example in this and the next slide where I'm going to show you what a predictive model can actually look like to make this a little more concrete of what the mechanics are, what you're learning from data. And this is sort of in the form of business rules. So we start with something quite simple. It turned out over this data from Chase with mortgage holders that the risk of losing a mortgage holder because they're going to leave, they're going to refinance, and suddenly you're going to have their debt with a different bank, you're not going to get any of the future interest payments. And the chances of that, it's a prepayment, they pay it all back too quickly. It's not the other kind of financial risk where you never get paid back at all. And the risk of that is so different just based on this one factor, interest rate. So those with a lower interest rate, you go to the left, we're in this one segment with a relatively low attrition rate of 3.8%, which I think was in a 3-month window. And the other segment was so much higher, 19%. That huge difference of those two different risk groups, of the risk of loss, just based on that one factor. So that's great. It validates the data. It's just one variable. It gives you a sense that the data is at least going to tell us this much. But in general, the whole goal of that golden egg, the whole learning process, what you want to get from data, is how to consider not just one thing at a time, but multiple things, everything you know about the customer, all the behavioral and demographic, consider them all together in concert for that individual. That's what the golden egg's job is, in order to render the best predictive score. So one way to do that, one of the most fundamental ways and most widely used ways, is called a decision tree. So we're going to start with this and continue to grow down, so it's an upside-down tree. This is a small excerpt of it. And even though it starts to get arcane, it's really one of the more friendly to the human eyes, in that sense, transparent methods, where you can understand what it's doing. So once you've got the model like this, the way you use it to ascertain risk level or predictive score for an individual is you start at the top, and each of these is a yes-no question. And if the answer is yes, you always go to the left. That's always the convention. Otherwise, you go to the right. And you're going to answer these yes-no questions to get down to one of these subsegments. It's kind of like marketing segmentation, but it was derived fully automatically by following the data, according to what the data is telling you, or telling the machine. So it's an automated process, right? And this is an example of a golden egg of a predictive model. Other ones are more mathematical, log linear regression. You may have heard of deep learning and neural networks and ensemble models. One way or another, these are all different mechanisms that are grown or learned and tuned by data in order to score individual customers based on everything you know about that individual customer. So coming back out of the techie part to the business application of what's the purpose, again, of predicting who's going to leave? Well, a retention offer. So this is a very popular thing. All the big cell phone companies do this. In telecommunications, it's so common. So you're going to get a brochure like this that's saying, hey, we want to retain you. We're willing to invest in a whole free device if you'll just commit to another year contract. But a side note here is this has potential to backfire. So there's a little stigma that you might get in a result. The consumer who feels incarcerated under the current contract commitment gets this retention brochure, and the light bulb goes on over her head because it reminds her, oh, that must mean my obligatory contract is up for renewal. It's going to expire soon. So now to heck with you and your deal, and I'm going to defect, which is something I had in mind anyway. So a customer like this is called a sleeping dog customer, also called do not disturb customers. We want to exercise the adage, let sleeping dogs lie. Don't trigger customers to leave who would otherwise stay. And that secondary issue is actually something that's effectively addressed with that more advanced, although much less common, but the more advanced form of predictive modeling I mentioned with Obama, which is called persuasion modeling, also called uplift modeling. And in fact, the Obama campaign really did see that effect where there were do not disturb voters. Voters that were predicted that if a volunteer knocked on their door, it would actually decrease the chance of them voting for their candidate Obama and increase the chance of them voting for the opponent Romney. So these people were very much left off the contact list, and the volunteers were not to go to that door and knock on it. So before I wrap up, let me just give you a quick overview about how this applies more generally. I think it's really important to recognize that this isn't just something that happens within commercial behavior of driving sales and acquiring customers and retaining customers. Beyond sales and marketing, there's also credit scoring and fraud detection, and beyond the commercial world, there's also law enforcement, all kinds of government applications, and then a huge amount of stuff happening in healthcare. In fact, in the Predictive Analytics World Conference Series, we now have vertical-focused events for government, healthcare, manufacturing, and workforce. So like predicting which customer is going to leave, you're also predicting which employee is going to leave. So this stuff has really taken hold, and it affects all of us as consumers every day, right? Our experience in modern society is dictated by how we're treated and served by organizations, who in turn are using predictive modeling to make those treatment decisions. Their outgoing behavior towards the outside world and consumers and suspects and voters and healthcare patients are being driven. Millions of decisions a day are driven for all these different application areas. Determining with a predictive model who to call, mail, approve, test, diagnose, warn, investigate, incarcerate, set up on a date, and medicate. So this is all very much happening. So I like to call predictive analytics the latest evolutionary step of the information age, because we've moved beyond the warehousing and collecting and managing of bigger and bigger data to applying science to learn from that data how to predict in order to drive all the main large-scale operations that that we do as organizations. So in a nutshell, just to wrap up, summarize, here are the takeaways. Big data is big because it's got big value in that it's predictive. This is the technology, this class of analytical methods called predictive analytics that learns from that data how to make those predictions. It needs to be used not just as a tech process, but in an organizational process that positions it correctly so that those outcomes that are being predicted, there's value to those predictions, and it's integrated, it's deployed, and it affects operations, right? Such as sales, right? And that's sort of the name of the game with inside sales products, is that within the sales apparatus, it's completely already deployed and integrated, right? So that's usually the biggest bottleneck, more than the technical bottleneck, is the deployment, is the integrating into existing processes outside just the core analytical processes. The actual, where the rubber hits the road, where you're making treatment decisions about how you interact with the outside world, right? That's the defining characteristic, is that it's prediction per individual. That's what makes it different from forecasting. Right? And we focus on two main value propositions or application areas: response modeling for acquisition and churn modeling for retention. That is, predicting who's most likely to buy in order to target acquisition activities in sales and marketing. And then also retention activities, which also need to be targeted to expend those resources more effectively by way of who's at most risk of actually leaving, of departing, of quitting, canceling. These are all synonyms. So, in a nutshell, here's how you get started, is you say, what's the lowest hanging fruit, right? Now, this first step, this is a catch-all slide. I didn't make it just for today. But this first step is what inside sales is effectively done, right? They've determined sales is where you want to be targeting efforts more effectively. They've determined that low-hanging fruit, and they've already integrated it. If you want to learn more in general, we have a hands-on guide. The URL's in the notes section. You'll see here. You can just Google it. And the Predictive Analytics Guide, these both point to one another, actually. And you can email me if you want some of these other resources. As I offered, I can provide you online access to the audiobook for my Predictive Analytics book. I also have this big, long list. For those of you who want to really become hands-on practitioners, what do I need to learn to be a data scientist or predictive analytics practitioner, what have you? There's a lot of articles about that, and I've been collecting them. So if you email me and ask for me for that, I'll just reply. I'll just copy and paste it for you. So I'm going to cut early because I've only got 1 minute and 45 seconds, and I know that you guys will like me better if we go to lunch 1 minute and 38 seconds early. So thanks for your attention, and let me know any questions at lunch. Thanks.